Hi, welcome to the section Object Detection with OpenCV. In this section, I am going to teach you how to do the object detection using Viola-Jones algorithm, popularly known as Cascade Classifier. Let us look into the output of the section. Consider the image has three goals. For this image, we will do the face detection, eye detection, and even the smile detection. It is not only limited to the three detections. You can apply this technique to get the whatever the object detection using the available pre-trained models using OpenCV. Let us go into the section to get more detail about this. I will see you inside the section. Hey guys, welcome back. In this section, we will discuss about object detection using OpenCV. We are going to look into the object detection algorithm that was used in OpenCV is Viola-Jones object detection framework. Object detection using Haar feature based Cascade Classifier is an effective object detection method developed by Paul Viola and Michael Jones. It is a machine learning based approach where a cascade function is trained from lots of positive images and also negative images. Then it is used to detect the objects in other images. And this Viola-Jones algorithm can also apply to any kind of object detection technique. However, our interest here is on the face detection. So let's look into the face detection perspective. The algorithm needs lots of positive images and negative images. That means positive images are images with faces and negative images are images without faces. In step 2, we will need to extract the features from it using Haar features. This is just like a convolutional kernel in convolutional neural network. As shown below are the kernels that is used for Haar feature extraction. In step 3, we'll take each feature as a single value obtained by subtracting sum of pixels under the white rectangle box and sum of pixels under the black rectangle box. So once we got the features, we will train this with a machine learning model. So this is what the process that was used in the Viola-Jones algorithm. And this is the most simplest algorithm that is used for the object detection technique. So without going much into the details, I request you to go to this original paper by Paul Viola and Michael Jones, which is Robust Real-Time Object Detection Technique. This is the original paper written by Paul Viola and Michael Jones. I request you to have a look into this paper on how to train your own object detection classifier using Viola-Jones algorithm, and it has very wide applications. I'll see in the next lecture more on how to do the object detection using Cascade Classifier in OpenCV. Until then, happy learning. Welcome back. In this lesson, we will see how to download the Haar Cascade Classifier. So what you would do is that just go to Google and type Haar Cascade Classifier, OpenCV, GitHub. And you can open the first link that was up here and it says Haar Cascade GitHub. Just click on that. Okay, so now you are in the OpenCV GitHub account and you can see that OpenCV/data/Haar Cascade Classifiers. So there you can see the bunch of Cascade classifiers that was readily available for you and you can use it for free. In this section, we will see how to use a Haar Cascade Classifier. And this is almost similar to applying to the all kinds of Haar Cascade classifiers that was readily available here. So now first what we will do, we will see the three kinds of Cascade classifier filters. That is the frontal face default, which is nothing but the face detection. And also we will see how to detect the eyes. And also we will look into the smile classifier too. So first what we will do, let's click on this Haar Cascade Classifier. Haar Cascade frontal face default. And now what you have is that you are in this particular file, click on raw. There you go, you are in this file and it is the Haar Cascade frontal face. So right click and save as, and save to your respective folder. So wherever you exactly want to save, you can save it. For example, I just want to save in this particular folder, and let me create a name of the folder is Cascade Classifier. Okay, so copy the path. Now save it in this particular folder. Click save. And now similarly save the Cascade classifiers just like how we did. For example, I want I now. Just click on this I. Click on raw. Right click, save as, and what are the name is there, just put the name and save. That's it. And do it for smile also. Yeah, click on this Cascade smile, click on raw and save as, save. Done. So this is how, like, you can download whatever the Cascade classifier that you want to do. You can easily save in your respective folder. I'll see you in the next lecture more on object detection with OpenCV. Until then, happy learning. Welcome. Now we will see how to use this Cascade classifier for face detection. And as you can see, I have loaded my Jupyter notebook in my respective folder where I have downloaded my Cascade classifier. And this is what the folder where my Cascade classifiers are there, like Haar Cascade _I, Haar Cascade frontal face default, and Haar Cascade _smile. And also I'm having some couple of images with me, and which I will do in this lesson. Next, what we will do now is that just need to open our new Jupyter notebook, go to file and create Python 3. I already created the Jupyter notebook with the file one_object detection cascade classifier. So let me open this. So this is the empty notebook. So first and foremost thing what we need to do is that let's import few necessary libraries that was required for object detection. Obviously it is OpenCV. So let's import numpy as np, also import cv2, execute it. Alright, so what we're trying to do in this lesson is that we are working on the face detection. Now we will see how to use this Cascade classifier to detect the face. So first let's load our image. I'll take an image equal to cv2.mread, and my images is there in my images folder, and let me take some image 0021.jpg and also display it using cv2.mshow, and this is my image and img, and cv2.wait key for give the delay of 0, and cv2.destroy all windows, execute it. And here we go, I'm having the picture of Ronaldo. So what I'll do is that I'll apply the Haar Cascade classifier to this image and I'll detect the face of the Ronaldo. Okay, so this is what I'm going to do in this lesson. So first let's load Cascade classifier. So the Cascade classifier that I want to load is frontal face. Frontal face is an object detection Cascade classifier which is already trained for 6000 plus images, and this will work decently good for the most of the images. Okay, let's load it. So this is the face cascade, and that's going to be equal to, I'll use a cv2.cascade classifier, and I just need to provide the path of the file. So my file is in the Cascade classifier and Haar Cascade frontal face _default.xml, and this is what the Cascade classifier that will detect the face. Execute it. Perfect. So done. So we have successfully loaded our model, nothing but Cascade classifier. Now what I need to do is that I just need to apply this Cascade classifier to my image img. So let us apply Cascade classifier to an image. So it's very simple to apply this Cascade classifier. It's almost simple. like face underscore cascade dot, and we have a method called detect multiscale version 2. And detect multiscale 2 will basically return the two parts. One is objects and second one is number of detections. And the inputs for the detect multiscale 2 is that just need to provide the image. And you can set what are the default settings that was there, and you don't need to worry about this. And it will remember it will return two parts, that is objects and number of detection. Object will basically give you the xy coordinates of the face and also width of the face and also the height of the face. And number of detections will tell you how many faces has been detected. At the same time, it will also display the number of features that is being matched. Okay, so it will return the two parts. One is faces, so how many faces, and number of detections. And that's going to be equal to, and just need to provide the image in an OpenCV array. Just provide this img, execute it. It'll take a while to calculate all the faces. So done. So what you can see here is that we have the faces, and you can print faces, and we got the coordinates of the faces. It says that this is the xy position, means the x position is 114 and y position is 40, and 196 and 196 defines width of the face and height of the face. So basically we'll get some square box and the position is this. And what you need to do is that if you calculate the diagonal point of this, and obviously we can draw the rectangle box of that. So we'll see that. And also let's also look into the number of detections. So in order to print the number of detections, use print number underscore detection. And it says we have the number of detections we have is 1, and 89 points. Basically the number of neighbors you can see here is the minimum number of neighbors. Basically the 89 indicates the number of neighbors that is matched is 89. So that's what it's going to say. It doesn't mean that you have 89 faces. This is number of points that is being matched, and the length of this is basically define the number of faces. So here the length is basically 1, so we have only one face. All right, so this is what the meaning of the output, what we got. And now what we will see is that we have the points, xy point, and we know the width of the face and we know the height of the face. And using that, can't we do the rectangle box? Yes, of course we can do that. So what we have here is the point 1 is basically my xy position, nothing but 114 and 40, and the point 2 is basically we got the width of the face and height of the face. Just add the 114 with width of the face, which is 196, and 40 with 196. What we can get is that one more diagonal position of this. And obviously if we have the two diagonal points, we can draw the rectangle, right? Yes, now we'll do how to draw the rectangle. So let's draw the rectangle. So we can draw the rectangle using cv2.rectangle. We have seen in the previous lesson how to draw the rectangle, and image 1 is img, and we can also have the point. The point is basically we can get the point 1 is pt1 and point 2 is pt2, and what we can get is the color. I just want to draw the green color, so green is 0, 255, 0, and thickness, let me define what are the default thickness it has. Now let us display it. So cv2.weight imshow, and this is what my face detection, and the name of the image is img, cv2.weight key of 0, and finally destroy all windows. Execute it. Here you go. You can see our object detection model, that is Cascade Classifier, can able to detect the face, and we have able to draw our rectangle box successfully. So this is how the power of Cascade Classifier. What it will do is that basically it will give the xy position. This is what my xy position, and what I calculated is that I calculated the diagonal point here. How? Using the width of the face and height of the face. The width of the face is 196 and height of the face is 196, and using that I can get the diagonal point, and using the cv2 dot rectangle I can draw this nice rectangle box. Awesome, right? Okay, it's not only that we can draw the rectangle, we can draw what other shape you want, you can really draw it. For example, let us also draw the circle on top of this. So let's close this, and now draw the circle. In order to draw the circle, basically what we require for the circle is we want image. Obviously we got the image and the center of the image and radius of the image. We can calculate the center of the image using width and height of the image. So basically width by 2 and height by 2, we can get the center of the image. And what is the radius of the image? It can be either width by 2 or height by 2. So let us calculate the center here. So let us calculate the cx. Cx equal to, since as you can see that cx is basically the width of the image by 2, 196 divided by 2. So since I want the integer, that's why I'm using the double slash, and I can get this. But here remember that this is basically we can get if at all, if you take the image in a square rectangle box and directly we can take 196 by 2. But here the problem is that we can't take directly 196 by 2. We need to add with that x position so that we can get the center. So what is the x position is? X position is 114. And similarly we can get the cy is that can be equal to 40 plus 196 double divided by 2. So we got the cx and cy. And the radius of the image, you can take whatever. You can take simply 196 by 2. You can take whatever width or height, because anyway that is same, and 196 double slash 2, and what we can get is the radius of the image. So now I think we are ready. So let's draw the circle, which is the image, and the center of the image is cx comma cy, and the radius of the image is r. Color, this time I'll select the different color, 0 comma 255 comma 255, and thickness is 2 pixels. Let me increase the thickness of the image. Now let us display it cv2 dot mshow, and this is the face detection circle. I mean, of course we also get the rectangle box because we already drawn here, and we also get circle on top of that. img and cv2 dot weight key of 0 and cv2 dot destroy all windows. Execute it. Awesome, right? You can see I can able to draw the circle. Awesome, right? You can see that I'm having a rectangle box and also I'm having the circle, and that is inside my rectangle box. This is really cool, right? So like this you can use the shapes and draw anything you want. Only thing you need to get the coordinates. If you got the coordinates and what are the shape you want, you can really able to do that. I will see you in the next lecture more on object detection with OpenCV. Until then, happy learning. Welcome back. In the previous lesson, we have seen how to do the face detection using OpenCV. But now the question is how to do it for the multiple faces. This is not the recommended method of way of doing the coding. Now let's see how to do the conventional way of face detection. So let us consider the image. I'm having the images here with me. Let us now consider the friends.jpg image. And if you see this is the friends.jpg, and what you can see here is that we can see 3 faces, means we have some multiple faces. Now let us see how to apply our face detection to this. So let us go to our code, and first and foremost thing what we will do is that let me read that image. img equal to cv2 dot mread and the images folder friends.jpg. Let us display it cv2 dot mshow img image img and cv2 dot weight key of 0, and similarly destroy all windows after that. Okay, so we have this image with me, and what I want to do is that I want to detect the three face. I need to draw some rectangle box on top of this. Okay, since we already did this Haar Cascade classifier, and let me load it again. Generally, that is what the more conventional way. So let me load this again. Now, what we need to do is that the step one is basically an object detection is apply cascade classifier to an image. So if you apply this cascade classifier to an image, let's say what you'll get is that we might get faces and we might get number of detections. Okay, so that's going to equal to face cascade dot detect multiscale to, and what you need to provide is image img. So that's it. So let me print my faces. And what we got here is that we can find the five faces, means this is one face, this is one face, and one more face here and one more face here. So that is what basically we got. But in reality, in our image, I had only 3 images. So why I'm getting these 5 images? So the reason behind this is minimum neighbors. Minimum neighbors is what the reason behind that. So what we need to do is that let's look into the number of detections too. So if you print the number of detections, and we got the 4 images we have, and obviously this you can see that we have the 4 neighbors are detected, and this is the 4 neighbors are detected, and for this face, maybe for this face I have detected the 104 neighbors has been detected, and for this face I'm having 84 neighbors are detected and 71 neighbors are detected. So obviously what you can see is that these are the 3 faces or definitely the contenders of the faces. But here there is a less likelihood that this is a face. So that's the reason what you will do is that generally we will set the minimum neighbors to some value, because even if one feature is detected, you might get that detection too, but that is could be a glitch. So that's the reason what you do is that just set the some threshold. Generally it's a good way to set some threshold, anything greater than 8 or 10, anything more than 8 or 10, that could be the good number. All right, so now what we have is that we got the minimum neighbors. I'm set to 8. Now let's look into that. I'm having the 3 faces now, and these are the 3 faces 104, 84 and 71. So we got the 3 faces now here. Now step number 2 is run a loop. Since I'm having the 3 faces with me, so I'll run a loop here. For obviously the first one is x, which is nothing but the x of the image, and y, and width, and h. Basically this for x, y position, width of the face, and height of the face. Now let me take for x, y, w, h in faces, running a loop. Now what I'm getting here is that I'm getting the loop now. So here what I can do, I might get even the multiple faces. I can able to draw it. So let us draw that. So cv2 dot rectangle, and obviously I'm getting that image. For to this image I want to draw a rectangle box, and the point 1 is basically x comma y, and the point 2 is x plus width, nothing but the diagonal point, plus y plus h. Next, the color of the box I want to draw is green color, 0 comma 255 comma 0. So that's it. So we got the thickness of the image. If you're okay, you can set the thickness, otherwise you can leave it to set to defaults. So that's it. So now what we have is that we can able to draw the 3 rectangle boxes on the 3 faces. Done. And now step 3, nothing, just display it. Display the image. So cv2 dot mshow, and this is my face detection, and followed by the matrix is img, and cv2 dot weight key of 0, and cv2 dot destroy all windows. Now execute it. Here you go. We have the three faces and we can able to draw the bogny box on top of this. Awesome, right? So just one thing what you need to do is that you should be a bit careful on selecting that minimum number of neighbors. Generally, it is a good way to select the more than 8. Anything more than 8 is also fine, but don't select the less numbers. It might lead to the overfitting that you might end up with the many boxes. Okay, this is how you can detect the multiple faces using Cascade Classifier and OpenCV. I'll see you in the next lecture more on object detection. Until then, happy learning. Welcome back. In this lesson, we will see how to do face as well as eye detection using OpenCV and Haar Cascade Classifier. Okay, so let's take the same image what we did in the previous lesson. That is, let me copy this, img equal to cv2.imread and in my images folder and friends.jpg, and this is what the image I'm using now. And obviously we saw how to do the three boxes, and now let's look into the eye detection too. For eye detection, the first thing what we need to do is that we need to detect the face first, and then we need to crop the face, and for that face we need to apply one more Haar Cascade classifier, that is eye. So now let us see how to do this. And obviously let me repeat the same procedure. Like the first one is the face cascade, and that's going to be equal to cv2.cascade classifier. Let me load that again, and my model is there in the cascade classifier, and it is my frontal face default. Similarly, eye cascade equal to cv2.cascade classifier, and let's load it again, cascade classifier, and the name of the cascade classifier I just want to load is Haar Cascade eye.xml. Now let's execute this. The next step what I want to do is I just want to detect the face. So let us apply this. The first step is, which is almost similar to a face detection, obviously it is a face detection. So since we already see how to do the face detection, so let me repeat the same process. Like the first one is that we need to get the number of detections and also faces from the detect multiscale. So faces and number of detections, and this is face equal to face underscore cascade, that's going to equal dot detect multiscale 2, and the image is img. Next one is the minimum number of neighbors, just please select to 8. Next, what we need to do is that we need to apply the for loop for x comma y comma w comma h and faces. Now just draw the rectangle box, cv2 dot rectangle, and what we need to do is that we need to draw the image 1. We need to provide the image, that is img, and the point 1 is x comma y, and the point 2 is x plus w comma y plus h. Next is the color. I just want to do the color is 0 comma 255 comma 0. So that's it. So with this what I can get is that I can get the face detection. The next step is eye detection. Here you need to remember one thing, that is in order to detect the eye we need to crop the image first. That is, we need to crop the face of the image first. So as we know the xy position and also the width and height of the image, the first thing what we need to do is that let's crop the image, that is face underscore ROI, nothing but my region of interest, is equal to, let's crop it, image of x colon x plus w. Okay, we need to start with number of rows, so it is y colon y plus h, then x colon x plus h, and this is what basically we are cropping the image, and we'll get the face ROI. So this face ROI we need to apply to our Haar Cascade Classifier of eye. Let us apply it. Step 3 is apply to Cascade Classifier. In bracket, it is eye. Oh, this is obviously this is eye detection, and this is first thing. Basically, it is the cropping the face. Okay, now let us apply this. In order to apply that, just we need to apply the same, just like how we did for the face detection. So obviously you'll get eyes, comma, number of detection of eyes. That's going to equal to eye underscore cascade dot detect multiscale, and what we have is that we need to provide the image, and the image that I need to provide is face underscore ROI. Okay, now we got the eyes and number of detections. Next step, what I want to do is that I want to draw the circle on the top of the eye. In order to draw the circle on top of the eye, what I want to do is that for EX, EY and EW, EH, basically eye XY position and eye width and eye height in eyes. So you might get the two eyes. Most of the cases you will get the two eyes. So EX, EY, EW and EH. Since I want to draw the circle, and for circle basically I want the CX is basically the center of the image or center of the eye, is could be EX plus EW divided by 2, and with this I can get the center position. But again, remember, this is just a part of the image, and in order to apply to the entire image, what we need to do is that we need to add with X, because that is the XY position of the face, and with that you can get the center of the eye. And similarly, if you want the center of Y of Ly, CY of I, and that is equal to Ly plus EY plus EH divided by 2, and similarly radius could be equal to EH divided by 2, and with that what you can get is that we can get center of the eye, and also we can get the radius of the eye. Now let's draw the circle, which is CV2 dot circle, and what is the image I want to apply is IMG, and the center of the image is CX, CY, and the radius of the image is R. The next one is the color of the image. Let me put some different color, 255, 0, 255, and thickness, let me put some thickness is equal to 2. That's it. We can get the circle around the eye. So what's the next step? Obviously display it. So CV2 dot show, and this is face eye detection, comma, we can get the matrix, and the matrix here is basically the image IMG, and CV2 dot weight key of 0, and CV2 dot destroy all windows. Execute it. That's it. Now you can see that we have the face detection as well as we have the eye detection also. Awesome, right? Hope you really enjoy this lesson. I will see you in the next lesson, more on object detection using OpenCV. Until then, happy learning. Hello everyone, welcome back. In the previous lesson, we have seen how to do the face and eye detection. Now what we will do, we'll also do face, eye, and also smile detection in one code. Obviously, I'll take the same image, that is my friends.jpg image. Let me copy and paste the friends.jpg image. And for this image, what I'll do, face, eye, and smile. We know how to do this face and also eye. Now let's also apply the eye detection to it. In order to do that, the code is exactly similar to our previous code. So what I'll do, I'll copy this code and paste it here. Here, what I want to do is that I just want one more cascade classifier, that is smile. So in order to get a smile cascade classifier, let's take cv2 dot cascade classifier and load the cascade classifier, which is Haar Cascade underscore smile dot xml. That's it. So we got it. And the first step, obviously the face detection. Remember, obviously you can get the smile on this face. So that's the reason the first step will be obviously that we need to detect the face. And for that face, what we will do the eye detection, and also we will apply the smile detection also. So exactly the same thing, we will do exactly the same thing however we get here. And here my next step will be the step number 4 is smile detection. And that's going to be equal to, I need to apply the smile detection for the face. So that's the reason what I'll do is that, like, if I apply to this face.roi, since the first step applied the eye, so that's the reason that may not get the correct positions. So that's the reason what we will do, let's put this before applying the rectangle box, and now we will copy this. So since what I'm doing here is that I'm just copying this portion to face underscore ROI. Now let us apply, now obviously you apply this face underscore ROI to cascade classifier, and obviously this is not step 2, and I'll rename this is to step 2, and step 3 is smile detection. Obviously we'll have the smiles, comma, number of detections underscore smile equal to smile underscore cascade dot detect multiscale 2, and we need to pass face underscore ROI. Now the next step is that apply the for loop for SX, means XY position of the smile, we'll get the mouth, and SY and SW, SH in smiles. Now let us draw the rectangle box, which is cv2 dot rectangle, and obviously the image is IMG, and the point 1, which is nothing but my XY position, X plus SX, and similarly the Y position is Y plus SY, and we got this XY position. The next step is that we need to get the diagonal position of this. Now the diagonal position is X plus SX plus SW, and the Y position is that Y plus SY plus SH. So that's it. So we will get now the box. The next is provide the color. This time I'll go for the blue color, which is 0, this is 255, 0, 0, and the thickness to 2 pixels. I think that's enough. Next, let me change this step 4, which is nothing but face, eye, and smiles. So with this, our code is ready. Let me execute this. Done. Now we can see that, we have the face detection, eye detection, and also the smile detection too. Awesome, right? I think now you guys are ready. You can try with the different faces and you will get some awesome results. I will see you in the next lecture on our project, which is face recognition. Means we are recognizing the name of the person, and also we'll see the emotion of the project, whether they're happy, sad, disgust, etc. And next we will create the Django web app, and we will create some beautiful website using that and integrate all the necessary functionalities into this. Coming next is very interesting part and you will love it. I will see you on that. Until then, happy learning.